Dear students, welcome and thank you for tuning in. We are continuing our videos about diffusion. This is the sixth video and we are going to solve an example about steady state diffusion in solids. We're going to use Fick's first law of diffusion to solve a problem. So we have a methylene chloride. It's a common ingredient of paint removers. Besides it being irritant, it's also maybe absorbed through skin, which is not good. We need to protect ourselves from this material. When workers use this paint remover, protective gloves should be worn all the time in order to avoid getting this material inside the body or in touch with the skin. We are going to use butyl rubber gloves. Workers will use these gloves. The thickness is 0.04 centimeter. They are used when methylene chloride is used as paint remover. Here's the question. What is the diffusive flux of the methylene chloride through this particular glove, which is the butyl rubber with a thickness of 0.004. So here's what's given to us. So the diffusion coefficient in butyl rubber is giving to us, which is D110 multiplied by 10 to the power minus 8. And we have the surface concentrations, which means that the concentration in two different locations where the butyl rubber will separate them. So outside where the methylene chloride will be abundant, we have concentration of 0.44 gram per centimeter cube, and on the skin we have 0.02 grams per centimeter cube. And we would like to see, this is very low, which means that we don't have any methylene chloride on the skin. We need to use the steady state diffusion formula, which is Fick's law, in order to find the J, which is the flux. And this is our example. To solve it, we're going to set up this schematic. So we say that this is the concentration 1, where I have high concentration of methylene chloride, and this is the skin, and this is my barrier, which is the glove, and the thickness of the glove is 0.04. If we're using the Fick's first law, J is minus D multiplied by dC over dx, which is the concentration gradient. We are simplifying it. So concentration 2 minus concentration 1 divided by the distance. This is the concentration gradient, dC over dx, and D is given. So this is D, the diffusion coefficient of butyl rubber. So each material has its own diffusion coefficient, and this is given. We have the concentration on the skin minus the concentration outside, where we are using the paint remover, divided by the thickness, and this is the value that you're getting. And please note that this is gram per centimeter square second. You could be converting this to other units and quantities. I would ask, as a practice, if you can transform J into kilograms per meter square second. That's a good exercise, and you can share in the comments below what is the solution for that and what is J in kilogram per meter square second. I hope this clarifies how we're using Fick's first law. This is an approximation, it's a simple problem, and depending on the concentrations, we're going to solve other problems in the coming videos. Thank you for watching. Until next time.